Example 6.3.2. This one says a 1-year $1,000 T-bill is issued at a price of $980.39 and offers a 2% yield. What is the new price if the yield increases to 5%? Okay, so some of this should look familiar. If you haven't already seen the previous example 6.3.1, it's worth having a look at that one before we go into here. And this problem is a great example of why bonds are such an ideal security to explore our time value money skills with. Once we've got the basics that we built up in chapters 3, 4, and 5, we know how to identify cash flows, we know what tools are available to solve for the different things we need to solve for. Well, now we can start developing our intuition and kind of playing with the tools that we've got with bonds because they're just relatively simple financial securities. Let's map this guy out first and then kind of appeal to our intuition that we built up before we start even calculating anything. Oops. All right, we have the same 1-year treasury bill. So there is only one cash flow the investor will have, cash inflow the investor will have, and that's it. The $1,000 face value received at the end of the year. The investor, the bond was trading for $980.39 when it had a yield of 2%. Right? That yield is now going to increase to 5%. So it's going to go from 2% to 5%. And the question is, what happens to the price? Okay, well, in the previous problem, we found that the price of the bond was $980.39 at a 2% yield. And the way we found the price was by finding the present value of the promised future cash flows. We discounted it back to today's dollars using the yield to maturity as the discount rate. We're going to do the same thing again, but before we even do any calculations, let's we'll quickly run through what type of cash flow we got here. It's a lump sum. So we know we can use the present value, future value of a lump sum formulas, time value money keys in the financial calculator, and a spreadsheet, all of which are in the text if you're interested in any of those. For this one, I'm actually going to look at both the formula and we'll plug it into the calculator real quick just to see how to do it. But the formula here gives us a little bit of intuition. So we want to find the present value of this $1,000 because that's the definition of yield to maturity. The yield to maturity is the rate, the discount rate that equates the present value of the promised future cash flows with the current price. So we can find the price by finding the present value of that promised future cash flow using yield to maturity as the discount rate. So let's use the present value of lump sum formula. To find the price, and the future value is 1,000. Discount rate in this case is 5%, expressed as a decimal is 0.05, so 1 plus 0.05 is 1.05, and the number of compounding periods in this case is 1. Now, before we do any calculation, let's compare this to what it would have been while the yield was 2%. We knew the price was $980.39, which was the present value of that 1,000 discounted at 2%. All right. Well, the only difference between the last example, where the price was $980.39, and this one, where we've got to find the new price, is that the yield has changed. It went from 2% in the previous example, and it increased to 5% in this example. So just looking at how the formula is laid out, if my denominator gets larger and everything else is held constant, where the $1,000 cash flow is still fixed, it's the same, timing is still the same, the number of periods is the same, it's 1 in both cases. The only thing that's changed is the discount rate that we're applying. We're applying a larger discount rate, so we're discounting the future cash flows more. And just looking at the formula, this guy's in the denominator, so when we increase the value of the denominator, we're dividing by a larger number, which means the overall quotient is going to be lower. It's going to be something less than $980.39. And we can appeal to our intuition a different way if the math doesn't make sense. Let's think about this from the investor's perspective. If the investor were to pay $980.39 and then receive $1,000 a year from now, the investor would have a 2% rate of return. The yield on the investment would be 2%. Well, since that future cash flow of $1,000 is fixed, if the investor is going to earn a higher rate of return on this investment, the only way that can happen is if he or she pays a lower price today for the bond, right? And it turns out that this relationship holds for all the bonds that we're going to look at today, and it can maybe be violated if you get some weirdness where you have bonds with varying cash flows. But for bonds with just fixed cash flows, if yield to maturity increases, it's going up like it did in this case, then price is going to go down. And vice versa. If yield to maturity decreases, that is the investor's rate of return, expected rate of return decreases, well, the only way that can happen is if the price increases. The investor pays more for the bond. And this relationship is worth writing down and thinking about and storing in your brain while we work these problems, because it'll make it to where you develop an intuition for what the right answer is and already know what to look for. So you can solve the problems a lot quicker and identify errors that come up a lot faster. But it also just helps wrap your mind around what's going on. Right? So if yield goes up, price goes down, it has to. Just the mechanics of the math say that that's going to happen every time because these cash flows are fixed. All right, now let's actually solve for the price on this one. We've got the formula set up here, so we'll just do 1,000 divided by 1.05. So we are getting a price of $952.38 roughly, which is lower than the $980.39 it was before. That's what we were expecting, so that looks right. And I'm pretty confident in the answer because it moved in the direction I expected. We can set it up with the time value money keys on this one, just so we've been consistent in the ways that we're solving these. I imagine most folks at this point have kind of transitioned over to the financial calculator, so I want to make sure we look at all of them. Now with this one, I could clear out my time value money keys, but the previous example is actually still stored in my calculator and probably is for yours as well. And I can check what values are on there by using my recall button. Say recall in, and that guy's still 1, like it was in the previous problem. In fact, let's go ahead and fill these in. Our N is going to be 1. Our interest rate is going to be 5. Present value is what we're looking for. Payment is 0, and then future value is a cash inflow of $1,000 from the investor's perspective. So the only thing that has changed here from the previous example is we changed the interest rate to 5%. So instead of clearing my time value money keys out, I'm going to go ahead and leave them in there, and I'm just going to replace the interest rate with 5. So 5 and I over Y. And then I'll just use recall to check the values on all the other keys. Present value can skip over because we're going to solve for that one, so it'll overwrite whatever's there. Can hit recall payment, it's still 0. Recall future value, and it's still 1,000. Of course, if you didn't just work the previous example and that isn't in your calculator, you'll need to enter those values. But once they're entered, we have 4 of the 5 values stored on there. We can solve for the 5th. In this case, present value, by hitting compute present value. And of course, I'm getting that same $952.38. Comes out as a negative when we use the time value money keys because the calculator is tracking the relative direction of the cash flows. And it's just saying that if you expect a cash inflow of $1,000 1 year from today, and you're going to earn a 5% rate of return, then you will need to have a cash outflow of $952.38. Of course, that doesn't happen with just the arithmetic, but the time value money keys will keep track of the direction of the cash flows there. Let's put that up on our timeline just so we kind of have a picture of what's going on. All right, and that is it. As always, you don't need to do both the formula and the financial calculator solutions. In this case, I thought it was just helpful to see what's going on with the math so that we can develop an intuition about the relationship between yield to maturity and price. And that is that they move in opposite directions with bonds.